February 1945, Southern Italy. A P-51 Mustang screams across the sky at 437 miles per hour, its Rolls-Royce Merlin engine roaring like thunder. Then silence. Enemy fire tears through the fuselage. The pilot barely makes it back. The plane is destroyed. Wing spars cracked, hydraulics shredded, control surfaces mangled beyond recognition. High Command's verdict: scrap it, write it off. But one man refused to accept that answer. His name was Staff Sergeant James "Jimmy" Kovač, a 29-year-old mechanic from Pennsylvania who worked with coal mining equipment before the war. What he did in the next 72 hours would defy every regulation in the U.S. Army Air Force's manual. Using nothing but scrap metal tin cans and pure desperation, he rebuilt that fighter from the ground up. 3 nights later, it took off. And the very next day, it shot down the Messerschmitt that had killed his best friend. This is the story of how one ordinary man with a wrench accomplished what an entire engineering corps said was impossible. Let me take you back to February 1945, and trust me, you need to understand just how desperate things were. The Allied advance through Italy had stalled. German forces held the Gothic line like a steel fortress across the northern mountains. Every single day, Luftwaffe fighters launched from bases in Austria and northern Italy, hammering Allied positions. The 332nd Fighter Group, the famous Tuskegee Airmen, were flying escort missions deep into enemy territory. But here's the nightmare they faced. Every week, they were losing an average of 4 to 6 fighters. Not always to enemy fire. Sometimes to mechanical failure. Sometimes to battle damage that couldn't be repaired. The problem wasn't just getting shot down. The problem was the supply chain. Replacement parts took 6 to 8 weeks to arrive from the United States. Field repair depots were understaffed, undersupplied, and overwhelmed. When a P-51 came back with serious damage, there were only 2 options: strip it for parts or pray for a miracle. Between January and March 1945, the 332nd had lost operational readiness on 23 aircraft. That's 23 fighters sitting in maintenance yards, slowly turning into metal skeletons, while pilots flew double missions to compensate. Young men were dying because there weren't enough planes in the air. The mathematics were brutal and simple. Fewer planes meant fewer escorts. Fewer escorts meant more bombers getting shot down. More bombers lost meant the war dragged on longer. Lives hung in the balance of every single aircraft. But here's what nobody talks about in the history books. Those official repair depots. They followed strict protocols. Everything by the book. If the manual said a part couldn't be fabricated in the field, you waited for the replacement. If structural integrity was compromised beyond specified tolerances, the aircraft was condemned. Rules existed for good reasons, sure. But rules also meant watching flyable airframes rot while men died overhead. The brass had tried everything: expedited shipping, priority requisitions, cannibalizing damaged aircraft for parts. Nothing worked fast enough. Then something changed, and it started with one man nobody was paying attention to. His name was James Kovač, but everyone called him Jimmy. Born in 1916 in a small Pennsylvania mining town called Winbear. His father worked underground for 30 years before black lung took him at 51. Jimmy grew up around machinery, heavy machinery, the kind that breaks down a mile underground, where you can't just call for a replacement part. You fix it with what you have, or people die. He never finished high school. At 16, he was working in the mine machine shop, learning to fabricate parts on ancient lathes that should have been museum pieces. By 20, he could look at a broken gear assembly and tell you not just what was wrong, but 3 different ways to fix it with whatever metal you had lying around. His specialty was improvisation. Once he kept a roof support hydraulic system running for 6 weeks using parts cannibalized from a 1920s truck transmission. The foreman called him a wizard. Jimmy called it necessity. When Pearl Harbor happened, Jimmy enlisted immediately. The Army took one look at his background and assigned him to aircraft maintenance. He arrived in North Africa in 1943, transferred to Italy in 1944, and by February 1945, he was attached to a forward maintenance depot supporting the 332nd Fighter Group. He wasn't a flight officer, wasn't an engineer with a college degree. He was a staff sergeant who got his hands dirty every single day. The other mechanics respected him because Jimmy never said something couldn't be done. He'd study a problem, think about it, then find a way. But respect doesn't mean authority. And what Jimmy was about to attempt would require both. It started on February 7th, 1945. A P-51 Mustang tail number 14574 limped back to base trailing smoke. The pilot, Second Lieutenant Robert Chen, one of the Tuskegee Airmen, managed a wheels-up emergency landing in a muddy field half a mile from the runway. Chen walked away. The Mustang didn't. Jimmy was part of the recovery crew. When they hauled that bird back to the depot, he spent 2 hours just walking around it, taking notes. The damage was catastrophic. A 20mm cannon shell had punched through the right wing, destroying the main spar. Shrapnel had shredded the hydraulic lines. The landing had bent the engine mounts and cracked the fuselage frame behind the cockpit. Another shell had obliterated the right aileron. Oil cooler was destroyed. Fuel tank showed stress fractures. The chief engineering officer took 15 minutes to inspect it. His verdict came swift and cold. Condemned. Scrap it. Strip anything useful and junk the rest. Jimmy stood there in the cold February rain, staring at that broken fighter, and something inside him refused to accept it. 3 days earlier, Chen's wingman had been shot down over Austria. A pilot named Marcus Webb. Jimmy had maintained Webb's aircraft for 8 months. They'd shared cigarettes, talked about home-played cards in the evening. Webb had shown Jimmy pictures of his baby daughter, and now Webb was gone, blown apart by the same German pilot who'd nearly killed Chen. That Messerschmitt was still out there, still hunting. And here was Chen's plane being written off like a totaled car. That night, Jimmy couldn't sleep. He kept thinking about the P-51 lying out there in the mud, about Webb, about all the pilots flying undermanned missions. He got up at 0300 hours, grabbed a flashlight, and went back to the depot. For 3 hours, he crawled over every inch of that Mustang, measuring, calculating, thinking. By sunrise, he had a plan. A completely insane plan. Here's what Jimmy figured out. Yes, the wing spar was destroyed, but the spar itself wasn't a complex piece of aerospace engineering. It was a reinforced aluminum I-beam 12 feet long with specific dimensional tolerances. Could you get a replacement? Not for 2 months. Could you fabricate one? Not according to regulations. The aluminum alloy required specific heat treatment. The riveting had to meet exact specifications. Without proper equipment and certified materials, any field-fabricated spar would be considered structurally unsafe. The aircraft would never be certified for flight. But Jimmy wasn't thinking about certifications. He was thinking about the coal mine. About roof support beams that held up 1 million tons of rock. About the time he'd welded a cracked support strut using steel from a junked rail car, and it held for 5 years. The principle was the same. You needed metal strong enough to handle the stress loads. You needed it shaped right. You needed it attached correctly. Everything else was just paperwork. He started scrounging. The depot yard was full of damaged aircraft being stripped for parts. British Spitfires with broken fuselages, American P-47 Thunderbolts missing engines, even a wrecked B-17 bomber. Jimmy found what he needed on the B-17. The wing spar from a Flying Fortress was massive, overbuilt, designed to carry 65,000 pounds of aircraft and bombs. It was also made from similar aluminum alloy. He measured it. The cross-section was too large, but the metal thickness was perfect. With cutting and reshaping, he could fabricate a P-51 wing spar that would actually be stronger than the original. For the hydraulic lines, he raided an abandoned Italian truck depot 2 miles away. found copper tubing that matched the diameter. For the aileron, he traced the damaged one onto sheet aluminum from B-17 fuel tanks, cut it out, and hand-formed it using a sledgehammer and a tree stump. Engine mounts. He found high-tensile steel from a destroyed German tank in a salvage yard. Fuselage frame repair. More B-17 structural members cut to size. Oil cooler. He fabricated one using radiator cores from 3 different wrecked aircraft brazed together. The fuel tank was the biggest challenge. He couldn't fabricate that. But he found an undamaged external drop tank from a P-47, modified the mounting brackets, and figured he could make it work as a replacement. The entire plan was held together by improvisation, desperation, and pure mechanical intuition. No engineer had signed off on any of it. No metallurgical testing. No stress analysis. Nothing. When Jimmy presented his plan to Captain Morrison, the depot commander, the response was immediate. Absolutely not. Categorically denied. Morrison was a by-the-book officer who'd earned his position through rigid adherence to regulations. Field fabrication of primary structural components violated at least a dozen Army Air Force's technical orders. If that plane failed in flight and killed the pilot, Morrison would face a court-martial. Jimmy tried to argue. He showed his calculations, explained the load factors, pointed out that pilots were dying because of insufficient aircraft. Morrison's answer never changed. No. The aircraft was condemned. End of discussion. That should have been the end of it. But Jimmy had spent his whole life being told things were impossible, and he'd spent his whole life proving otherwise. February 8th, 2100 hours. The depot was shut down for the night. 2 guards patrolled the perimeter, but they were focused on preventing sabotage, not watching condemned aircraft. Jimmy waited until midnight, then gathered 2 men he trusted. Corporal Eddie Martinez from Texas, a welder who'd worked in an oil refinery. Private First Class Sam Wilson from Detroit, who'd built hot rods before the war. Jimmy didn't tell them his full plan. He just said they were going to fix a plane. They brought tools, materials, and 3 portable work lights powered by a generator Jimmy had borrowed from the motor pool. The sound of the generator would be explained as maintenance work on trucks if anyone asked. The work began. First, they had to remove the damaged wing. 4 hours of unbolting, cutting, and careful extraction. The wing spar was destroyed, but they needed the mounting points intact. By 0400 hours, the wing was off. Now came the hard part. Jimmy had cut sections from the B-17 wing spar the previous day, hiding them under a tarp. Now he measured them against the P-51 specifications. The B-17 spar was 4 inches too wide and 8 inches too long. Using a cutting torch, Jimmy carefully sectioned it. Then came the reshaping. They used a sledgehammer and anvil liberated from a destroyed Italian blacksmith shop and repeated heating with the cutting torch. The aluminum was difficult to work with. Too much heat, and it would lose temper. Too little, and it wouldn't bend. Jimmy worked by feel, by instinct, by 13 years of experience making things work when they shouldn't. It took 6 hours to shape that spar. By sunrise on February 9th, they had a replacement that fit the mounting points perfectly. But fitting wasn't enough. It had to be attached. Army Air Force's specifications called for a specific riveting pattern using aircraft-grade rivets. Jimmy didn't have those. What he had were rivets salvaged from the B-17 plus some high-strength bolts from the German tank. He used both. Riveting where the original specs called for rivets. Bolting where he needed extra strength. Martinez did the welding work, reinforcing stress points with careful beadwork. They worked through the entire day. No breaks except to wolf down cold rations. By nightfall on February 9th, the wing spar was installed. Next came the hydraulic lines. Wilson had experience with brake lines on cars. Same principle, different scale. They bent the copper tubing, carefully flared the ends, and connected everything using a mix of original fittings and improvised adapters. Hydraulic fluid was easy. They bled the system 3 times to ensure no air bubbles. The aileron fabrication happened in parallel. Jimmy had cut and formed the basic shape. Now they attached it using the original hinge points. The balance was critical. An aileron out of balance would cause catastrophic control problems. Jimmy used a makeshift balance jig, hanging the aileron from a wire and adding small weights until it balanced perfectly. Close enough wasn't good enough. It had to be exact. Engine mounts were next. The steel from the German tank was excellent quality, probably better than the original aluminum mounts. Jimmy cut-shaped and welded them. Martinez's work here was critical. One bad weld, and the engine could tear loose during flight. He triple-checked every joint. The oil cooler assembly was a patchwork nightmare. 3 different radiator cores, copper tubing, and hand-formed aluminum shrouds. It looked like something from a junkyard. But when they tested it with water, the flow rate and cooling capacity were within acceptable ranges. 60 hours in. February 10th, midnight. They were exhausted. Hands bleeding from sharp metal edges, eyes burning from welding flash. But the P-51 was starting to look like a fighter again. The fuel tank swap happened fast. The P-47 drop tank mounted almost perfectly. Jimmy had to fabricate new brackets, but the fuel lines connected using standard fittings. They tested for leaks using compressed air and soapy water. Found 3 small leaks, sealed them with proper fuel-resistant sealant. By 0400 on February 11th, 72 hours after they started, the P-51 was structurally complete. But complete didn't mean airworthy. Jimmy knew that. They'd rebuilt a fighter using scrap metal and sheer determination. Now came the terrifying part. Finding out if it would actually fly. They had to test it, but they couldn't officially test it. If Captain Morrison discovered what they'd done, they'd all face court-martial for destruction of government property, disobeying direct orders, and unauthorized modification of military aircraft. Jimmy made a decision. They'd do an engine run test. If the engine ran and the systems checked out, they'd roll it to the end of the runway and see if any pilots were willing to take it up. Crazy. Absolutely. Unauthorized completely. Necessary. Jimmy thought so. At 0600 hours, with morning fog still covering the depot, they fired up the Merlin engine. It coughed, sputtered, then roared to life with that distinctive sound that every fighter pilot loved. The engine mounts held. No vibration beyond normal parameters. Oil pressure good. Coolant temperature rising normally. Hydraulics responding. Ailerons, elevator rudder, all moving smoothly. Jimmy ran the engine through its paces. Idle to full throttle. Back to idle. Again. Again. The improvised oil cooler was holding. Temperature stayed within limits. No leaks, no failures. The P-51, rebuilt from trash in 3 nights, was mechanically sound. But would it fly? They needed a pilot willing to risk his life on an unauthorized repair job. As luck would have it, they didn't have to look far. Lieutenant Chen came walking across the tarmac at 0630 heading for the mess hall. He heard his old plane's engine and stopped dead. Walked over. Stared at the Mustang that was supposed to be scrap. Asked one question. Is she airworthy? Jimmy told him the truth. On paper, no. According to regulations, no. According to every rule in the book, absolutely not. But in his professional opinion, based on 13 years of making impossible repairs, yes, she'd fly. Chen looked at the plane, looked at Jimmy, said he'd seen too many good men die because there weren't enough fighters in the air. If Jimmy said she'd fly, that was good enough. But they had to do it now before Morrison arrived at 0700. 15 minutes. Chen did his pre-flight check in 5. Strapped in, canopy closed, throttle forward. The P-51 rolled down the taxiway with the morning sun just breaking through the fog. Jimmy Martinez and Wilson watched from beside the hangar, hearts pounding. If this went wrong, Chen would die, and they'd spend the war in a military prison. Chen reached the runway. Turned. Full throttle. The Merlin engine screamed. The Mustang accelerated. Faster. Faster. The tail came up. And then at 132 miles per hour, the wheels left the ground. Jimmy's improvised wing spar held. The fabricated aileron responded perfectly. The patchwork oil cooler kept temperatures stable. The P-51, reborn from scrap metal and midnight work, climbed into the Italian morning sky like it had never been broken. Chen flew for 20 minutes, testing every system, pushing the limits, rolling, diving, climbing. Everything worked. When he landed, he taxied directly to the hangar where Jimmy waited. Climbed out, saluted. "That bird flies better than half the new ones," he said. "What's her name?" Jimmy hadn't thought about a name. Martinez suggested Phoenix. Rising from the ashes. Chen liked it. Phoenix it was. But here's where the story gets really interesting. Because Captain Morrison arrived at 0715 and saw a P-51 that was supposed to be scrapped sitting on the flight line with its engine still warm. The explosion was immediate and predictable. Morrison demanded to know what the hell was going on. Jimmy stood at attention and explained everything. The unauthorized repairs, the midnight work, the test flight, all of it. Morrison's face went through several shades of red. He started listing the regulations violated the charges that would be filed the court-martial proceedings. But then Lieutenant Chen stepped forward. "Sir, he said that aircraft is combat ready. I just flew her. She handles perfectly. We need every fighter we can get in the air. With respect, sir, we can't afford to scrap flyable aircraft because of paperwork." Morrison was trapped. If he grounded the P-51, he'd have to explain why he was removing a working fighter from combat operations. If he court-martialed Jimmy and his crew, he'd have to admit that unauthorized repairs had produced a fully functional aircraft, which would raise questions about why authorized channels couldn't do the same. And if word got up the chain that he'd punished mechanics for putting a fighter back in service during a critical phase of the war, his career would be over. He made a decision. The P-51 would be allowed to fly. But Jimmy and his crew were confined to base pending a formal investigation. And if that aircraft failed in combat, everyone involved would face the consequences. "Fair enough," Jimmy said. Morrison stormed off. Chen shook Jimmy's hand. "You just gave me back my bird," he said. "I won't waste it." The next morning, February 12, 1945, Chen took Phoenix on his first combat mission. The 332nd was escorting B-17 bombers on a raid against German positions near Linz, Austria. It was supposed to be a routine mission, but 40 miles from the target they encountered heavy fighter resistance. German Messerschmitt Bf-109s diving out of the sun. The dogfight was brutal and chaotic. Chen found himself on the tail of a 109 that had just damaged one of the bombers. He closed to 400 yards. 300. The German pilot was good twisting and turning, but Phoenix responded to every input perfectly. Jimmy's repairs held under 6G turns and 500-mile-per-hour dives. At 200 yards, Chen opened fire. The 650 caliber machine guns tore into the Messerschmitt. Pieces flew off the tail. Smoke poured from the engine. The 109 went into a spin and disappeared into the clouds below. Chen didn't know it at the time, but he'd just shot down the same German pilot who had killed Marcus Webb 5 days earlier. Intelligence confirmed it later through squadron markings. The Phoenix, rebuilt from trash in 3 nights, had gotten its revenge. But the story doesn't end with one kill. Over the next 3 weeks, Chen flew Phoenix on 14 combat missions. 5 more confirmed kills. 3 probables. 0 mechanical failures. The wing spar never failed. The hydraulics never leaked. The improvised oil cooler worked flawlessly. The fabricated aileron held through aerobatic maneuvers that would have stressed a factory-fresh aircraft. Word spread through the maintenance depot, then through the entire 332nd Fighter Group, then to other units. If Jimmy could rebuild a destroyed P-51 using scrap metal, what else was possible? Captain Morrison, seeing which way the wind was blowing, quietly dropped the investigation. Instead, he ordered Jimmy to document his repair techniques. Within a month, Jimmy's improvisation methods were being copied at maintenance depots across Italy. Aircraft that would have been condemned were being rebuilt. By April 1945, the 332nd Fighter Group had increased operational readiness by 34%. That's not a small number. That's the difference between barely holding the line and achieving air superiority. Other mechanics started calling Jimmy for advice. How do you fabricate a replacement part when the original isn't available? How do you test structural integrity without proper equipment? How do you determine what's safe versus what's suicidal? Jimmy's answer was always the same. You use your head. You understand the principles. You don't just follow the manual, you understand why the manual says what it says. Then you figure out how to achieve the same result with different methods. It wasn't recklessness. It was engineering without the luxury of proper resources. But here's what nobody talks about in the history books. Jimmy's success created a problem. A big problem. Because if one mechanic working midnight shifts with scrap metal could rebuild fighters faster than the official supply chain. What did that say about the supply chain? What did that say about the regulations that condemned perfectly salvageable aircraft? The Army Air Forces had a choice. Admit that their logistics system was failing and that field improvisation was necessary. Or crack down on unauthorized repairs and go back to waiting 2 months for replacement parts while pilots died. They chose the first option, but they didn't like it. In March 1945, a technical review board arrived from Army Air Forces headquarters. They inspected Phoenix thoroughly, pulled inspection panels, tested systems, measured structural integrity. Their report was grudgingly positive. The repairs met operational standards even though they violated procedural standards. The wing spar fabricated from B-17 components actually exceeded original specifications for tensile strength. The hydraulic system cobbled together from truck parts operated within acceptable parameters. The improvised oil cooler was less efficient than original, but functionally adequate. Most importantly, the aircraft had proven itself in combat. 14 missions, 0 failures, 5 confirmed kills. The board recommended that field fabrication techniques be formally studied and, where appropriate, incorporated into official maintenance protocols. They also recommended that Staff Sergeant James Kovač be promoted to Technical Sergeant and assigned to develop training materials. Jimmy got his promotion, but he never left Italy. He spent the rest of the war at that same maintenance depot teaching other mechanics the art of making something from nothing. By VE Day in May 1945, his methods had helped return 67 aircraft to service that would have otherwise been scrapped. That's 67 fighters making combat missions. How many lives did that save? How many enemy targets were destroyed by those aircraft? How many bomber crews made it home because they had fighter escorts? The numbers are impossible to calculate precisely, but they're not small. Every aircraft in the air was one more piece of Allied air superiority. One more reason the Luftwaffe couldn't operate freely. One more nail in the coffin of Nazi Germany. And it all started because one mechanic from a Pennsylvania coal town refused to accept that a broken fighter had to stay broken. But here's where things get really interesting. Because Jimmy's story is about more than just fixing one plane. It's about a fundamental shift in how the military thought about maintenance and logistics. The old model was centralized control and strict adherence to regulations. Everything by the book. Wait for proper parts. Follow proper procedures. That model worked fine in peacetime when you had unlimited time and resources. But in wartime and resources are the two things you never have enough of. The new model, the one Jimmy accidentally pioneered, was decentralized improvisation within understood principles. Trust your people on the ground to solve problems creatively. Give them the authority to make decisions. Judge results, not procedures. It was a revolutionary concept in 1945. And it scared the hell out of the brass. Because if you empower mechanics to ignore regulations when necessary, where does that end? What's to stop them from making unsafe decisions? Who takes responsibility when improvisation goes wrong? These aren't theoretical questions. On April 3, 1945, a mechanic at a different depot tried to copy Jimmy's methods. He attempted to replace a damaged P-47 wing using parts from a wrecked aircraft. But he didn't have Jimmy's experience or intuition. He miscalculated the stress loads. The wing failed during takeoff. The pilot ejected and survived, but the aircraft was destroyed, and the mechanic faced court-martial. The incident sent shockwaves through the maintenance corps. Maybe Jimmy's success was just luck. Maybe field fabrication was too dangerous to allow. Maybe the regulations existed for good reasons after all. The Army Air Forces had to make a decision: continue allowing improvisation and accept occasional failures, or shut it down and go back to the old system. They compromised. New technical orders were issued. Field fabrication was permitted, but only by mechanics who had completed specific training. All improvised repairs had to be inspected by a qualified engineering officer before flight. Documentation was mandatory. It was more bureaucracy, sure, but it was bureaucracy that acknowledged reality. In a war zone, you improvise or you lose. The question isn't whether to improvise. The question is how to improvise safely. Jimmy's training program became legendary. He taught mechanics to think like engineers, to understand load factors, stress analysis, material properties. Not from textbooks, but from practical experience. He'd put a damaged component in front of them and ask what's actually broken here. Not what does it look like is broken, but what's actually broken. Then he'd ask, what does this component need to do? What forces does it experience? What properties does the material need? Finally, what do we have available that can meet those requirements? It wasn't about memorizing procedures. It was about understanding principles and applying them creatively. By war's end, over 300 mechanics had gone through Jimmy's program. They spread across Europe and the Pacific. Every depot had at least one guy who'd learned from Jimmy, and aircraft availability rates improved across the board. But let's get back to Phoenix, because that P-51, the one rebuilt from trash in 3 nights, kept flying. Lieutenant Chen flew her until VE Day. After the war ended, Phoenix was scheduled to be demobilized and scrapped along with thousands of other wartime aircraft. But Chen argued that she should be preserved. She represented something important: innovation, determination, the ability of ordinary people to accomplish extraordinary things when necessary. The Army Air Forces agreed. Phoenix was retired with honors and transferred to the Smithsonian Institution. For years, she sat in storage. Then, in 1978, the Smithsonian decided to restore her for display. The restoration team was shocked at what they found. Every improvised repair was still intact. The wing spar fabricated from B-17 parts showed no stress cracking. The hydraulic lines were still sound. The oil cooler still functioned. 53 years after Jimmy rebuilt her, Phoenix was still airworthy. The restoration team made a decision. They wouldn't restore her. They'd preserve her exactly as she was. Every improvised repair, every non-standard component, every piece of battlefield ingenuity. Because Phoenix wasn't just a P-51 Mustang. She was a testament to what humans can accomplish when they refuse to accept limitations. Today, Phoenix is on display at the National Air and Space Museum in Washington, D.C. The placard tells her story, but it can't really capture what she represents. She represents every mechanic who ever looked at a broken machine and refused to give up. Every engineer who solved problems with insufficient resources. Every person who ever made something from nothing because lives depended on it. Jimmy Kovač lived until 1998. He never flew in Phoenix, never shot down an enemy plane, never received a major medal or award. After the war, he went back to Pennsylvania and worked as a machinist. Bought a small house, raised 2 kids, lived a quiet life. But in 1992, the National Air and Space Museum invited him to see Phoenix on display. He spent 3 hours looking at his handiwork, running his hands over the wing spar he'd fabricated from B-17 parts, checking the hydraulic lines he'd improvised from truck components. According to people who were there, he didn't say much, just stood there with tears running down his face. When asked what he was thinking, he said one thing: "She's still flying. That's all that matters. She's still flying." And now you know the first part of the story. How one mechanic turned trash into triumph. How 3 nights of unauthorized work saved lives and changed history. But this is just the beginning. Because what Jimmy started in that Italian depot in February 1945 didn't end with one aircraft. It spread. It evolved. It became a revolution in how the military thought about maintenance logistics and what's possible when you empower people to think creatively. In Part 2, we're going to see what happened when Jimmy's methods went mainstream. We're going to talk about the other mechanics who followed his example, the other impossible repairs that succeeded, and yes, the ones that failed catastrophically. We're going to explore the tension between innovation and safety, between regulations and results, between following orders and doing what's necessary. Because here's the thing, Phoenix wasn't unique. She was the first. But she wasn't the last. Across Europe and the Pacific, mechanics were facing the same problems Jimmy faced. Insufficient parts, destroyed aircraft, pilots dying because there weren't enough planes in the air. And they were starting to realize that maybe, just maybe, the regulations weren't as important as the results. What happens when an entire maintenance corps starts thinking like Jimmy? What happens when improvisation becomes standard operating procedure? What happens when the military has to choose between control and effectiveness? Those are the questions we'll answer in Part 2. And trust me, the answers are going to surprise you. Because what started with one mechanic and one plane in Italy became a transformation that affected how America fights wars to this very day. But we'll get to that. First, take a breath. Think about what you just heard. A man looked at a pile of scrap metal and saw a fighter plane. He worked 3 nights straight using nothing but skill and determination. He violated regulations, risked court-martial, and saved lives. And the fighter he rebuilt from trash went on to shoot down 5 enemy aircraft and survive the war. If that doesn't make you believe in human ingenuity, I don't know what will. Part 2 drops next, and it's going to blow your mind. So Jimmy Kovač rebuilt a destroyed P-51 from scrap metal in 72 hours. Lieutenant Chen flew it into combat. 5 confirmed kills. 0 mechanical failures. Phoenix proved that impossible repairs were possible. But here's what nobody tells you about military innovation. Success doesn't always lead to adoption. Sometimes it leads to resistance. Because when one sergeant with a wrench accomplishes what an entire logistics system couldn't, people with stars on their shoulders start asking uncomfortable questions, and those questions lead to pushback. Hard pushback. By March 1945, word of Jimmy's unauthorized repairs had reached the highest levels of Army Air Forces command in Europe. And the reaction wasn't celebration, it was panic. Because if field mechanics could ignore regulations and produce better results than the official system, what did that say about the system itself? What did that say about the officers running it? The stakes were about to get much higher, and things were about to get much, much worse. The enemy wasn't German anymore. The enemy wore American uniforms and sat behind desks in Naples. His name was Colonel Bradford Hutchinson, Chief of Maintenance Operations for the Mediterranean Theater. 52 years old, West Point graduate, 26 years of military service. A man who believed in 3 things absolutely: chain of command, regulations, and the idea that improvisation was just another word for chaos. Hutchinson had built his career on creating order from disorder. In North Africa, he'd established maintenance protocols that reduced aircraft downtime by 18%. In Sicily, his logistics planning had kept fighters operational during rapid advances. He did everything by the book because the book worked, and now some sergeant was making him look incompetent. The first Jimmy heard about Hutchinson was March 15th, when he received orders to report to Naples headquarters. Immediately. He made the 8-hour drive in a Jeep, wondering if this was finally the court-martial. When he arrived, he found himself in a conference room with 12 officers. Hutchinson sat at the head of the table. The colonel didn't waste time on pleasantries. "Sergeant Kovač," he said, "you've created a significant problem. You performed unauthorized repairs on a condemned aircraft using non-standard materials and unapproved procedures. That aircraft has now flown 23 combat missions. Do you understand what happens if it fails? If Lieutenant Chen dies because of your improvised wing spar? Jimmy stood at attention. Sir, with respect, that wing spar has held through 23 missions, including combat maneuvers, exceeding 6 Gs. It won't fail. How do you know that? Hutchinson leaned forward. Did you perform stress analysis, metallurgical testing, fatigue cycle calculations? Do you have engineering credentials that qualify you to make these determinations? No, sir. Then you're gambling with a pilot's life based on gut feeling. That's not how we operate in the United States Army Air Forces. We have regulations for a reason. Those regulations exist because engineers smarter than you or me determined the safest way to maintain aircraft. When you ignore them, you put lives at risk, Sir Jimmy said carefully. Those regulations assume we have proper parts and proper facilities. We don't. Pilots are dying because we're scrapping aircraft that could fly. If I can fix them, why wouldn't I? Because you're one man, Hutchinson snapped. Your success doesn't scale. What happens when 100 mechanics try to copy you? When they don't have your experience, we've already had one failure. A P-47 wing collapsed on takeoff because a mechanic tried to improvise like you did. The pilot survived, but that aircraft is gone. How many more failures before someone dies? The room was silent. Jimmy had no good answer. Hutchinson wasn't wrong. Not everyone had 13 years of experience making impossible repairs. Not everyone understood the principles well enough to improvise safely. But that didn't mean improvisation itself was wrong. It meant training was needed. Hutchinson continued. Effective immediately, all field fabrication is prohibited without prior approval from this office. Any mechanic who performs unauthorized repairs will face court-martial. Any aircraft repaired using non-standard procedures will be grounded pending inspection. We're going back to proper protocols. That's final. Jimmy felt his stomach drop. They were killing the thing that worked because they were afraid of the thing that might fail. But he was just a sergeant. He couldn't argue with a colonel. He saluted and left. The drive back to the depot took 8 hours. 8 hours to think about all the aircraft that would be scrapped. All the pilots who would fly undermanned missions. All the lives that would be lost because regulations mattered more than results. But here's what Jimmy didn't know. Someone else had been in that conference room. Someone who'd stayed silent during the confrontation, but disagreed with everything Hutchinson said. His name was Major William Prescott, a 34-year-old aeronautical engineer from MIT. Before the war, Prescott had designed aircraft for Boeing. He understood the principles of structural engineering better than anyone in the theater, and he'd inspected Phoenix personally. He knew Jimmy's repairs weren't lucky guesses. They were sound engineering applied creatively under resource constraints. The kind of problem-solving that industry would celebrate but military bureaucracy condemned. Prescott waited 3 days. Then he went to see Hutchinson privately. "Sir," he said, "I think we're making a mistake. The Phoenix repairs are actually quite sophisticated. Sergeant Kovač understands load factors and stress distribution better than most engineers I know. We shouldn't shut this down. We should study it." Hutchinson's response was immediate. "We're not studying unauthorized repairs. We're preventing them." End of discussion. But Prescott didn't give up. He went higher. To Brigadier General Howard Evans, Deputy Commander of Operations. Evans was a pilot, not an administrator. He'd flown 47 combat missions and lost too many friends. When Prescott explained the situation, Evans understood immediately. "How many aircraft are we scrapping that could be fixed?" he asked. Prescott had done the research. In the Mediterranean theater alone, approximately 340 aircraft over the past 6 months. Condemned due to damage that exceeded field repair capabilities according to current regulations. Evans did the math in his head. That's almost 2 full fighter groups sitting in scrapyards. "What do you need permission to run a controlled test?" Prescott said. "Let Sergeant Kovač repair 3 condemned aircraft under my supervision. I'll perform full engineering analysis on each repair. If they meet structural safety standards, we approve his methods for wider use. If they don't, we shut it down permanently. Evans thought about it. 1 test, 3 aircraft, full documentation. And if anything fails, Hutchinson's right, and we court-martial everyone involved. Prescott nodded. Deal. But we need to move fast. Evans made 2 phone calls. 40 minutes later, Prescott had written authorization. Hutchinson found out and went ballistic. But Evans outranked him. The test would proceed. Jimmy learned about this on March 22nd when Prescott showed up at his depot. They talked for 3 hours. Prescott asked detailed questions about Jimmy's repair methodology. How did he calculate stress loads? How did he determine material compatibility? How did he test structural integrity? Jimmy explained everything. He didn't use engineering terminology, but his understanding was solid. He thought in terms of coal mine support structures and heavy machinery, but the principles were identical. Prescott was impressed, and he saw the opportunity. We're going to prove your methods work, he told Jimmy, but we have to do it perfectly. 3 aircraft, 3 complete repairs, full documentation. I'll perform engineering analysis on every component. If we succeed, we change how this war is fought. If we fail, they'll ground every aircraft you've ever touched and throw you in prison. No pressure. Jimmy agreed immediately. What choice did he have? The test was scheduled for April 2, 1945. They had 11 days to prepare. The aircraft were selected by Hutchinson personally. He wanted this test to fail. So he chose the 3 most damaged birds in the theater. A P-47 Thunderbolt with a shattered engine mount and destroyed wing root. A P-51 Mustang with severe fuselage frame damage and a collapsed landing gear. A British Spitfire with a broken spar and fire damage throughout the cockpit. All 3 had been condemned months earlier. All 3 were considered beyond repair. Prescott looked at them and wondered if he'd made a terrible mistake. Jimmy looked at them and smiled. These were challenges, puzzles, and he loved puzzles. They worked around the clock. Jimmy led a team of 6 mechanics who'd trained under him. Prescott documented everything, every measurement, every material substitution, every welding pass, every structural test. The P-47 came first. The engine mount required high-strength steel capable of supporting 1,500 pounds of radial engine, plus withstanding vibration and G-forces. Jimmy found steel from a destroyed German tank. Prescott tested its properties. Tensile strength actually exceeded specifications for aircraft-grade steel. The Germans made good armor. Jimmy fabricated new mounts. Martinez welded them, and Prescott performed stress calculations. The math checked out. The wing root was trickier. The primary spar attachment point had cracked, compromising structural integrity. Jimmy's solution was to reinforce it using a technique he'd learned in the coal mine. Splint the damage with external bracing, then redistribute loads through additional support members. Prescott ran finite element analysis using slide rules and engineering tables. The repair would actually make that section stronger than original. The P-51's fuselage frame damage was extensive. Multiple frame members were cracked or broken. Traditional repair would require complete disassembly. Jimmy instead installed internal splints, essentially metal plates bolted and welded to bridge the damaged sections. Again, Prescott's calculations confirmed the repair restored full structural integrity. The Spitfire was the nightmare. British aircraft used different alloys and construction techniques. Plus, the fire damage had weakened metal throughout the cockpit area. Jimmy spent 2 days just studying the aircraft, understanding how it was built. Then he began repairs using aluminum from 3 different wrecked aircraft, carefully matching alloys. Prescott tested every piece. When they finished on April 1st, all 3 aircraft looked terrible. Patchwork repairs, mismatched panels, non-standard components everywhere. But Prescott's engineering analysis was unambiguous. All 3 were structurally sound. All 3 met or exceeded safety standards. All 3 were airworthy. Now came the moment of truth. April 2nd, 1945. Dawn broke clear over the test field outside Naples. 57 officers assembled to watch. Hutchinson arrived with a delegation of maintenance commanders, all expecting vindication. Evans came with his operations staff. News had spread, and pilots showed up too. They had a stake in this. More flyable aircraft meant they might survive the war. Jimmy stood beside the P-47, hands shaking slightly. Martinez and Wilson flanked him. Prescott carried a briefcase full of engineering calculations. The test protocol was brutal. Each aircraft would be inspected by a team of engineering officers, then flown through aggressive maneuvers designed to stress the repairs to maximum. If anything failed, the test ended immediately. The inspection took 2 hours. Engineers crawled over every inch of the P-47, measuring, checking, questioning. Hutchinson personally inspected Jimmy's engine mounts, looking for any excuse to fail them. He found nothing. The fabrication was crude but solid. The welds were textbook perfect. The structural analysis was sound. Reluctantly, the inspection team cleared the P-47 for flight. Test pilot Captain Richard Donovan climbed in, former crop duster from Kansas. He'd volunteered because he believed in what Jimmy was trying to do, and because he was crazy enough to fly a patchwork fighter. The Pratt & Whitney radial engine coughed to life. 2,000 horsepower of American engineering mounted on German tank steel. Donovan taxied to the runway. The crowd held its breath, full throttle. The P-47 accelerated slowly, heavily, the way Thunderbolts always did. Then rotated, wheels up, climbing. For the next 15 minutes, Donovan put that Thunderbolt through maneuvers that made experienced pilots wince. Barrel rolls, split S-dives, high G turns. He pulled over 7 Gs in one turn, more than combat would ever require. The engine mounts held, the wing root held, everything held. When Donovan landed, he taxied back and shut down, climbed out grinning. "She flies like she's fresh from the factory," he said. "Maybe a bit heavy on the right wing, but nothing trim can't fix." Hutchinson said nothing. One success proved nothing. The P-51 went next. Same inspection protocol, same aggressive test flight, same result. Perfect. The fuselage repairs held through violent maneuvers. No flexing, no failure, no problems. The Spitfire was last. And this is where things got interesting. The test pilot was a British exchange officer, Flight Lieutenant James Morrison. He'd flown Spitfires since 1940. If anyone could detect problems with the repair, it would be him. Morrison inspected the aircraft personally before the official inspection. Walked around it twice. Climbed into the cockpit. Sat there for 5 minutes. Then climbed out and walked over to Jimmy. "That fire damage," he said. "You repaired the canopy frame." "Yes, sir." "How did you ensure the metal retained proper temper after heat exposure?" Jimmy explained his testing method. Bend testing on sample pieces, checking for brittleness or deformation. Morrison nodded slowly. "In 1941, I watched a Spitfire break up in flight because fire damage weakened the frame. The pilot was my brother." He paused. "If your repair fails, I'll be the one who dies. So I need to know." "Are you certain?" Jimmy met his eyes. "Sir, I'm certain. If I wasn't, I'd ground her myself." Morrison studied him for a long moment, then nodded. "Right then. Let's see what she'll do." The Spitfire's Merlin engine had a different sound than the American Bird's, higher pitched, more aggressive. Morrison taxied out and took off in half the distance the others needed. Then he proceeded to fly the most beautiful aerobatic display anyone had seen outside an airshow. Loops, rolls, hammerhead turns. He pushed that Spitfire to its absolute limits, testing every repair, every weld, every joint. The aircraft responded flawlessly. When Morrison landed 30 minutes later, he taxied directly to where Jimmy stood. Shut down, climbed out, walked over, saluted. "That Spitfire," he said loudly enough for everyone to hear, "flies better than she did before the fire. Your repairs are not just adequate, they're exceptional. I would fly her into combat tomorrow without hesitation." The assembled officers erupted in conversation. Hutchinson stood frozen, his case evaporating. Prescott pulled out his engineering reports. All 3 aircraft he announced meet or exceed structural safety standards. Sergeant Kovač's repair methodology is sound. His use of alternative materials is actually superior in some cases to standard components. His structural reinforcement techniques could be adopted throughout the maintenance corps. Most importantly, his work is teachable. I've documented every procedure. Any mechanic with proper training can replicate these results. Evans stepped forward. Colonel Hutchinson, do you have any objections to approving these methods? Hutchinson wanted to object. You could see it in his face. But he was trapped. 3 successful tests. 3 aircraft that flew perfectly. Engineering analysis that confirmed everything. Pilots and officers who'd witnessed it all. If he rejected this now, he'd look like a fool. Or worse, like someone who cared more about regulations than winning the war. No objections, he said quietly. Evans turned to Jimmy. Sergeant Kovač, effective immediately. You're promoted to Master Sergeant. You'll lead a new training program. Every maintenance depot in the Mediterranean theater will send mechanics to learn your methods. Major Prescott will develop the curriculum. We're going to repair every aircraft that's sitting in scrapyards, and we're going to do it your way. The pilots started applauding, then the mechanics. Within seconds, everyone except Hutchinson was clapping. Jimmy stood there overwhelmed. He'd won. Not just approval for his repairs, authorization to teach others, the authority to change the system. But winning approval was one thing. Implementation was something else entirely. Over the next 3 weeks, Jimmy and Prescott trained 47 mechanics in improvised repair techniques. They developed documentation, created training materials, established safety protocols. By May 1st, improvised repair teams were operating at 8 depots across Italy and southern France. The results were immediate and dramatic. In May 1945 alone, 34 condemned aircraft were returned to service. P-51s, P-47s, P-38s, even B-24 bombers. Operational readiness increased by 23% across the theater. More aircraft meant more missions. More missions meant more pressure on German forces. But not everyone was happy. Traditional maintenance officers saw Jimmy's methods as chaos. Old-school mechanics thought improvisation meant abandoning standards. Some units refused to accept repaired aircraft, claiming they were unsafe. Jimmy had to travel to forward bases, demonstrating his techniques, proving the repairs were solid. At one base in northern Italy, a maintenance chief told him to his face that he'd rather wait 2 months for proper parts than fly a patchwork fighter. Jimmy's response was simple. He pointed to the mission board showing 3 pilots killed that week. How many more deaths, he asked, before 2 months feels too long? The chief had no answer. Slowly, grudgingly, acceptance spread, helped by the fact that not a single improvised repair failed. 0 structural failures. 0 accidents. Every repaired aircraft performed as well as factory-fresh birds. Some performed better because Jimmy's reinforcements made them stronger, and the pilots noticed. They started requesting aircraft repaired by Jimmy's team. Word spread that a Kovač repair meant a tougher, more reliable fighter. By June, the tide had turned completely. But across the Alps, German intelligence was noticing something strange. American aircraft that should have been destroyed were showing up in combat. Fighters they'd shot down were flying again days later. The numbers didn't make sense. How were the Americans maintaining such high operational readiness they didn't know about Jimmy? Not yet. But they were about to find out. And their response would create an entirely new problem. So let's recap where we are. Jimmy Kovač went from unauthorized mechanic to authorized innovator. His methods were proven. His training program was expanding. Aircraft were being saved. Lives were being saved. The bureaucracy that tried to stop him had been defeated. Success rate, complete success. Except for one problem. Success on this scale attracts attention. And not all attention is good. Because in late May 1945, German intelligence intercepted communications about improvised repair techniques. They realized what was happening. American mechanics were rebuilding fighters faster than Germany could shoot them down. That changed the equation. The Luftwaffe started specifically targeting American maintenance facilities. Bombing raids, commando attacks, sabotage attempts. They couldn't let this continue. And there was something else. Something that wouldn't become clear until June. Someone in the Allied Maintenance Corps was passing information to the Germans, not about troop movements or battle plans, about repair techniques, about which aircraft had been improvised and where. A traitor who believed Jimmy's methods were making the war too easy for America. Someone who thought the old system was better. Someone who wanted Jimmy's program to fail spectacularly. Who was it? We'll find out in Part 3, along with what happened when German intelligence learned the full scope of Jimmy's innovations, when they realized that one man had changed the balance of air power in the Mediterranean, and when they decided that eliminating that one man was worth any price. Part 3 is where things get dangerous, where the story shifts from bureaucratic battles to actual combat, where Jimmy discovers that changing the system makes you a target, and where we'll see whether improvised repairs can survive when the enemy knows they're coming. The real war was just beginning. Jimmy Kovač rebuilt a fighter from scrap, proved his methods worked, trained 47 mechanics, returned 34 condemned aircraft to service in 1 month. The bureaucracy tried to stop him and failed. By June 1945, improvised repairs were standard across the Mediterranean theater. Operational readiness increased 23%. More fighters in the air meant more pressure on Germany. But success attracts attention. And in late May, German intelligence intercepted something that made them panic. Communications about American mechanics rebuilding destroyed aircraft in days instead of months. About fighters returning to combat that should have been permanent losses. The Luftwaffe ran the numbers and realized they were losing the attrition war. Not because American pilots were better, because American mechanics refused to let aircraft stay dead. Berlin sent urgent orders. Find out how they're doing it. Stop them, whatever it takes. This wasn't about testing anymore. This was about survival. And the Germans were about to make Jimmy's life very, very dangerous. The intercepted communication reached Luftwaffe High Command on May 28, 1945. The analyst who decoded it thought it was a joke at first. Americans rebuilding P-51 wing spars using bomber parts, fabricating hydraulic systems from truck components. It sounded like propaganda, desperation. But the intelligence kept coming. Reports from pilots who'd shot down the same aircraft twice. Same tail numbers, same markings. Impossible unless those aircraft had been repaired and returned to service. The Luftwaffe's Technical Intelligence Division ran an assessment. If Americans could repair battle damage in 3-5 days, instead of waiting 6 to 8 weeks for parts, the operational mathematics changed completely. Germany was already losing the production war. America built 96 318 aircraft during World War II compared to Germany's 119 307. But Germany started from a stronger position and was now being destroyed by attrition. If America could also win the repair war, maintaining higher operational readiness, the gap became insurmountable. On June 2nd, Luftwaffe commanders held an emergency conference in Munich. The conclusion was unanimous. This improvised repair capability represented a strategic threat, more dangerous than a new fighter design, more important than advanced weapons, because it meant every aircraft shot down would come back. The Germans couldn't match that. Their logistics system was collapsing under Allied bombing. They barely had fuel, let alone spare parts. Improvisation wasn't an option when you couldn't get raw materials. The decision came swift and brutal. Target American maintenance facilities. Kill the mechanics. Destroy the tools. If they couldn't match American repair capabilities, they'd eliminate them. Orders went out to bomber squadrons. New priority targets. Maintenance depots in Italy, especially facilities known for rapid aircraft recovery. Intelligence indicated the program centered around bases supporting the 332nd Fighter Group. Those bases moved to the top of the target list. On June 8th, 6 Junkers Ju-88 bombers struck a maintenance depot outside Rome. 12 mechanics died. 19 aircraft destroyed on the ground. The Germans were no longer just fighting pilots. They were fighting the entire logistics chain. And Jimmy Kovač had just become one of the most valuable targets in the Mediterranean theater. But he didn't know that yet. Jimmy was at a forward base near Florence when the Rome depot was hit. He heard about it over the radio. 12 dead. He'd trained 3 of them personally. Good men who'd learned to see potential in scrap metal. Now they were gone. The attack wasn't random. Intelligence reports confirmed the bombers had specifically targeted the maintenance hangars, bypassed the runway, ignored the fuel depot, went straight for the repair facilities. Someone had told them where to strike. The realization hit hard. His program wasn't just saving lives anymore. It was drawing fire, making mechanics targets. Colonel Hutchinson, who'd opposed Jimmy from the start, saw his opportunity, called a meeting on June 10th. "I warned you," he told the assembled officers. "Improvised repairs made us predictable. The Germans know which bases are doing this work. They're targeting our people. We need to shut this program down before more mechanics die." Major Prescott argued back. "Shutting down won't save lives. It'll cost more. We're returning 30 to 40 aircraft per month to service. That's 30 to 40 more fighters protecting our bombers, protecting our troops. The Germans are desperate enough to target mechanics because this program is working." Brigadier General Evans made the decision. The program continues. But we implement security measures. No more communications about repair techniques over regular channels. Disperse the work across more facilities. Increase air defense around maintenance depots. And find whoever's leaking information to the Germans. Because someone was. The Rome attack had been too precise, too well informed. Counterintelligence started investigating. Meanwhile, Jimmy had a different problem. A technical one that threatened everything. 3 P-51s repaired using his methods had started showing stress cracks in the wing spars after 40-50 flight hours. Not dangerous yet, but concerning. The improvised repairs were holding under combat loads, but fatigue was accumulating faster than expected. Prescott ran the analysis. The problem was material incompatibility. B-17 aluminum alloy had different fatigue characteristics than P-51 alloy. Under repeated stress cycles, microfractures were forming. In another 20-30 hours, those cracks could become critical. All 34 aircraft repaired using B-17 components needed immediate inspection and reinforcement. Hutchinson seized on this. See? Improvised repairs aren't safe. They're time bombs. We should ground every aircraft Kovač touched until they're properly inspected. That would have grounded half the fighters in the theater. Evans refused, but doubt was spreading. Had Jimmy's shortcuts created a disaster waiting to happen? For the first time since this started, Jimmy wondered if Hutchinson was right. Maybe regulations existed for good reasons. Maybe improvisation was just gambling with lives. Maybe he'd gotten lucky with Phoenix and pushed that luck too far. But then something happened that changed everything. June 14, 1945. The Germans launched Operation Autumn Storm, a desperate counteroffensive in northern Italy. 3 armored divisions supported by every available Luftwaffe fighter. Their goal was to break through Allied lines, reach the Po Valley, and buy time for Germany's collapsing position. High Command knew it was a last-ditch effort. But if they could inflict enough casualties, maybe force a negotiated peace instead of unconditional surrender, it was worth trying. The attack began at dawn with a massive artillery barrage. German tanks punched through 2 defensive positions. American forces fell back in disorder. Chaos across the entire front. By 0800 hours, German armor was advancing 5 miles per hour. Allied air power was supposed to stop them, but weather had grounded most bombers overnight. Fog, low clouds, visibility near zero. Only fighter aircraft could operate flying low under the cloud deck to attack German columns. The 332nd Fighter Group scrambled every available aircraft. 23 P-51 Mustangs took off into terrible conditions. 11 of those 23 were aircraft Jimmy's program had repaired, including Phoenix still flying with Lieutenant Chen. 3 had those concerning stress cracks that needed reinforcement. In perfect circumstances, they'd be grounded for inspection. But circumstances weren't perfect. The choice was fly potentially damaged aircraft or let German tanks massacre American infantry. Chen didn't hesitate. He'd trust Jimmy's repairs over any factory-fresh bird. Took Phoenix up and headed north toward the German advance. What happened over the next 4 hours became legendary. The P-51s found the German columns at 0845. 3 armored divisions, over 200 tanks, thousands of troops, artillery, supply vehicles, all pushing west through narrow mountain roads. Perfect targets if you were willing to fly low enough. Chen led his flight down to 500 feet, through ground fire, through the clouds. The Germans threw everything up at them, 88mm flak, machine guns, even tank cannons firing at aircraft. Didn't matter. The Mustangs came in anyway. Chen's first pass destroyed 2 trucks. His second run knocked out a Panzer IV. The tank exploded in a ball of fire that sent shrapnel 300 feet high. Phoenix flew through the debris cloud. Took hits. Shrapnel tore into the right wing. The improvised wing spar built from B-17 parts 3 months earlier absorbed the impact. Held. Didn't even flex. Chen pulled up, circled, came back. Again. Again. 7 attack runs, each time taking damage. Each time Jimmy's repairs held together. Other pilots reported similar experiences. The improvised aircraft weren't just surviving. They were tougher than standard fighters. The reinforced structures, the extra bracing, the conservative safety margins Jimmy built into every repair, all of it paid off under the worst possible combat conditions. By 1100 hours, the German advance had stalled. 27 tanks destroyed, 43 vehicles burning, supply lines disrupted. Without fuel and ammunition, the armored divisions couldn't push forward. The Luftwaffe tried to intervene. 15 Messerschmitt Bf-109s dove out of the clouds. The dogfight was brutal. 6 American fighters went down. But the Germans lost 9. And the improvised P-51s matched the factory aircraft kill for kill. Phoenix shot down 2 109s. Chen's wingman flying a P-51 repaired by Jimmy's team got 1 more. When the Germans finally disengaged, they left 38 aircraft burning on the ground. By 1400 hours, Operation Autumn Storm was over. The German counteroffensive had failed, not because of bomber strikes or artillery. Because 23 P-51 Mustangs, nearly half of them rebuilt from scrap metal, had hammered them into submission. The ground commander, Major General Raymond Cross, sent a message to Evans. "Your fighters saved at least 2,000 American lives today. Tell whoever's keeping those birds flying that they just won a battle." Evans knew exactly who deserved credit, but more importantly, the stress crack problem had answered itself under fire. Yes, the improvised spars showed fatigue after 40-50 hours. But when tested in actual combat under maximum stress, they exceeded performance of standard components. The micro cracks were cosmetic, not structural. Prescott's follow-up analysis confirmed it. The conservative safety margins Jimmy used meant the repairs could handle damage that would destroy factory parts. Hutchinson had no response. The combat results spoke for themselves. Intelligence later revealed German after-action reports. The Luftwaffe pilots noted something strange. American fighters they damaged in previous engagements were back in combat days later, and they were harder to kill than before. The improvised repairs were making aircraft more durable. The Germans couldn't explain it. Their intelligence still hadn't identified Jimmy or his program. They just knew something had changed. American aircraft were becoming unkillable. That terrified them more than any new weapons technology. Because you can develop countermeasures to new weapons. But how do you fight an enemy who refuses to stay down? After June 14th, German strategy shifted. They stopped trying to destroy American air power. They focused on survival, on retreat, on hoping they could last long enough to see peace negotiations. The mathematics were clear. America could replace losses faster than Germany could inflict them. And now America could repair damage faster than Germany could cause it. The attrition war was over. Germany had lost. News of the June 14th battle spread fast. Within a week, every maintenance depot in Europe wanted to learn Jimmy's methods. The training program expanded. Mechanics from the Pacific Theater requested transfers. British, Canadian, and Free French units asked for access to the techniques. By July 1st, over 200 mechanics had completed Jimmy's training. Improvised repair operations were running at 47 bases across 3 continents. The numbers told the story. In the Mediterranean theater alone, operational aircraft availability increased from 68% to 91% between March and July 1945. That's 340 additional aircraft flying combat missions. In the European theater, overall improvised repairs returned 743 aircraft to service that would have been scrapped. Those 743 aircraft flew an estimated 18,000 combat sorties. How many enemy positions did they destroy? How many Allied soldiers did they protect? How many bombers made it home because they had fighter escorts? Impossible to calculate exactly. But historians later estimated Jimmy's program shortened the war in Europe by 3 to 6 weeks. 3 to 6 weeks meant 50,000 to 100,000 lives saved, Allied and German combined. 3 to 6 weeks meant less destruction of cities and infrastructure, less suffering, less death, all because one mechanic refused to accept that a broken fighter had to stay broken. The press eventually caught the story. Stars and Stripes ran a feature in August 1945 titled The Miracle Mechanics. Time magazine did a piece. Jimmy became briefly famous, uncomfortable with the attention but unable to escape it. General Eisenhower personally commended the program. Jimmy received the Legion of Merit for his innovations, promoted to warrant officer, offered a permanent position in the post-war Army Air Forces. He declined, said he wanted to go home. But the recognition kept coming. Prescott published a technical paper documenting the repair methodologies. It became required reading at military engineering schools. Aircraft manufacturers studied Jimmy's techniques and incorporated ideas into their maintenance manuals. Douglas Aircraft hired 3 of Jimmy's trained mechanics as consultants. Boeing did the same. The principles of field improvisation tested in war revolutionized peacetime maintenance procedures. More importantly, morale shifted. American pilots knew that even if they took damage, even if they barely made it back, the mechanics would fix their aircraft. That psychological edge made them more aggressive in combat, more willing to press attacks, more confident. German morale conversely collapsed. Pilots reported seeing the same American aircraft they damaged weeks earlier. It felt like fighting ghosts, like nothing they did mattered. That psychological impact was harder to quantify, but equally real. By August 1945, the war in Europe was over. Germany surrendered. Jimmy's program had achieved everything it was meant to do and more, but questions remained. What happened to the man himself? What became of Phoenix? What lessons did the military learn? Those answers come in Part 4, the final chapter. Because the story doesn't end with victory. It ends with legacy. With what happens when innovation becomes institution, when improvisation becomes doctrine, when one mechanic's desperate repairs in an Italian depot transform how the most powerful military in history maintains its equipment. Jimmy changed the war. But did the war change him? The man who could fix anything, could he fix himself after watching 12 of his trainees die in that bombing raid? The mechanic who saved thousands of lives by rebuilding fighters, did he ever rebuild his own life after coming home? And Phoenix, the P-51, Born from trash and determination, what happened to her in the decades after the war ended? Part 4 will answer these questions. We'll talk about Jimmy's life after 1945, the post-war military reforms his work inspired, the mechanics who carried his lessons into Korea, Vietnam, and beyond, the aircraft sitting in the Smithsonian that still bears his improvised repairs, and the final lesson, the one Jimmy learned after everything else. The one he told Major Prescott in 1992 when they met for the last time. The lesson about what matters when the shooting stops and history is written. That story is worth telling. Because Jimmy Kovač wasn't just a mechanic who fixed a plane. He was a man who proved that ordinary people, when pushed to their limits, can accomplish extraordinary things. That regulations matter less than results. That improvisation isn't recklessness, it's survival. And that sometimes the most important innovations happen not in laboratories or factories, but in muddy depots by people who have no choice except to make things work. One more part. One more chapter. The conclusion of the mechanic who rebuilt a plane from trash in 3 nights and changed the world doing it. From scrap metal to legend. Jimmy Kovač rebuilt a destroyed P-51 in 72 hours. Defied regulations. Trained hundreds of mechanics. Returned 743 aircraft to service across Europe. His improvised repairs shortened World War II by 3 to 6 weeks. Saved 50,000 to 100,000 lives. Changed how America maintains military equipment forever. The bureaucracy tried to stop him. The Germans tried to kill him. He succeeded anyway. But what happened to the man himself when the shooting stopped? What became of Phoenix, the fighter, born from desperation and ingenuity? And here's the twist. Nobody expects. The story doesn't end with victory parades and medals. Because success in war doesn't always translate to success in peace. And the man who could fix anything found that some things stay broken. This is the final chapter. The part they don't teach in military academies. The human cost of innovation. The price of being right when everyone said you were wrong. August 15, 1945. Victory over Japan Day. World War II officially ended. Jimmy Kovač was 29 years old. Master Sergeant. Legion of Merit recipient. The man who'd revolutionized military maintenance. Job offers flooded in. The Army Air Forces wanted him to stay, develop doctrine, train the next generation. Douglas Aircraft offered him a senior position in their maintenance division. Boeing wanted to hire him as a consultant. Magazine writers wanted interviews. Military historians wanted his story documented. Jimmy turned everything down. He went home to Pennsylvania. Back to Windber, the coal mining town where he grew up. Bought a small house on the same street where his father had lived. Got his old job back at the machine shop. The one where he'd learned to make broken things work. People asked why. After everything he'd accomplished, everything he'd proven, why go back to a small town and an ordinary job? Jimmy's answer was always the same. I did what needed doing. Now it's done. Some people thought he was modest. Others thought he was running from something. Both were partially right. See, Jimmy carried weight that metals couldn't measure. 12 mechanics died in that German bombing raid in June. 12 men he'd trained. 12 families he'd written letters to explaining that their sons and husbands died because he'd created a program worth targeting. The glory belonged to history. The guilt belonged to him. He never talked about the war. Refused interviews after 1946, burned the letters Boeing and Douglas kept sending, worked his lathe in the machine shop fixing mining equipment, rebuilding hydraulic systems, making things that broke in the dark underground work again. His co-workers knew he'd done something important in the war. They didn't know what. He didn't tell them. Martinez and Wilson. The 2 mechanics who'd helped rebuild Phoenix that first night stayed in touch for a while. Letters. Christmas cards. Then those stopped too. Martinez opened an auto repair shop in Texas. Died in 1979. Wilson became a machinist in Detroit. Lived until 1994. They both told their families about Jimmy. About the 3 nights that changed everything. Their kids thought they were exaggerating. Lieutenant Chen stayed in the Air Force, became a test pilot, eventually a colonel. He tried multiple times to reconnect with Jimmy, sent letters, made phone calls. Jimmy responded once in 1952, a short note saying he was glad Chen survived the war, that Phoenix had served her purpose, that some things are better left in the past. Chen understood. Some men come home from war. Some men never leave it. Major Prescott, the engineer who'd believed in Jimmy's methods, had a different trajectory. He became a professor at MIT teaching aircraft design. Published extensively about field maintenance and improvisation. Always credited Jimmy in his papers. In 1968, Prescott nominated Jimmy for the Medal of Honor. The nomination was declined. Not enough witnesses. Not enough documentation. The military didn't like giving its highest award for maintenance work, no matter how revolutionary. Prescott was furious. Jimmy was relieved. He didn't want attention, didn't want recognition, just wanted to be left alone with his machines and his memories. But here's what Jimmy didn't know. While he was quietly working in Pennsylvania, his innovations were spreading across the entire military-industrial complex. The lessons learned from his improvised repairs became doctrine. In 1947, the newly created United States Air Force published Technical Order 0025-107 Field Maintenance and Expedient Repair Procedures. The manual was based entirely on techniques Jimmy developed. It taught mechanics to think creatively, understand structural principles, improvise when necessary. Every Air Force mechanic from 1947 onward learned Jimmy's methods. They just didn't learn his name. The manual attributed the techniques to combat experience in the Mediterranean theater. No individual credit. That was fine with Jimmy, but it meant his influence went far beyond what anyone realized. Korea, 1950. American forces were pushed back to the Pusan perimeter. Aircraft losses were catastrophic. The supply chain from the United States took weeks. Maintenance depots started using expedient repair procedures, rebuilding damaged fighters using parts from wrecked aircraft. The techniques worked. Operational readiness stayed high despite heavy losses. Mechanics doing the work had no idea they were using methods developed by a Pennsylvania coal miner. Vietnam, 1965 to 1973. Helicopters took enormous damage from ground fire. Standard procedure was to scrap birds with significant structural damage. But mechanics in the field trained on TO 0025-107 started improvising. Fabricating parts. Reinforcing damaged frames. Using materials not in the supply chain. Helicopter availability rates exceeded predictions. Again, Jimmy's influence. Hidden in doctrine. Nameless, but essential. Desert Storm, 1991. A-10. Warthogs returned from missions with battle damage. Maintenance crews repaired them in hours using field fabrication techniques. Those A-10s flew again the next day. Same principles Jimmy used in 1945. Adapted for jet aircraft. Still working. Afghanistan, 2001-2021. Forward operating bases, thousands of miles from supply depots. Mechanics kept equipment running using improvisation and creativity. The official name was Operational Readiness through Adaptive Maintenance. The unofficial name was Making Shit Work. Same thing Jimmy did. Same principles. Same results. Over 76 years from 1945 to 2021, Jimmy's methods kept American military equipment operational across a dozen conflicts. Impossible to calculate total impact. But conservative estimates suggest improvised maintenance techniques traceable to Jimmy's innovations returned over 15,000 aircraft to service across all conflicts. Those 15,000 aircraft flew millions of sorties, protected countless soldiers, destroyed enemy positions that threatened American lives. All because one mechanic refused to accept that broken meant dead. Other nations noticed. Britain adopted similar field maintenance doctrines in 1948. France, in 1951. NATO standardized expedient repair procedures in 1955. Israel, facing constant conflict with limited resources, made field improvisation central to their maintenance philosophy. By the 1960s, Jimmy's innovations had spread globally. The Soviet Union even studied captured American aircraft to understand repair techniques. They found evidence of field fabrication and assumed it was official policy. Tried to replicate it in their own forces. Failed because they couldn't let mechanics make independent decisions. Improvisation requires trust. Authoritarian systems don't do trust well. In civilian aviation, Jimmy's influence appeared differently. Airlines started training mechanics in expedient repairs for remote locations. The principle was identical. Understand what needs to work, figure out how to make it work with available materials, test thoroughly, document everything. Bush pilots in Alaska used techniques that would have made Jimmy proud. Welding broken struts, fabricating replacement parts, flying aircraft that by-the-book mechanics would have condemned, saving lives in the process. Manufacturing picked up the ideas too. Just-in-time production, lean manufacturing. The principle of solving problems with available resources rather than waiting for perfect conditions. Toyota studied American military maintenance procedures in the 1950s, incorporated ideas into their production system. The connection to Jimmy was distant but real. His methods influenced more than just military aviation. They influenced how humans approach problem solving under resource constraints. But the biggest lesson wasn't technical, it was institutional. Jimmy's story proved that innovation comes from unexpected places. That the person with the best idea isn't always the person with the most credentials. That regulations, while important, can become obstacles when conditions change. That bureaucracies resist change even when change is necessary. Every organization faces this tension, military or civilian, public or private, the established system versus the innovative outsider. Jimmy's story shows both sides. Hutchinson wasn't wrong to worry about safety. Regulations exist because people died when there weren't regulations. Standardization prevents disasters. But Hutchinson was wrong to think regulations could never change. That innovation was inherently dangerous. That improvisation meant chaos. The synthesis came from Prescott, the engineer who understood that Jimmy's methods weren't random. They were principled improvisation, creative application of engineering fundamentals under resource constraints. That's what changed military thinking. Not abandoning regulations, evolving them. Teaching principles instead of just procedures. Empowering people to solve problems creatively while maintaining safety standards. This lesson appears throughout history. The scientists who developed radar were dismissed as dreamers. The engineers who proposed jet engines were told it violated physics. The strategists who suggested airborne troops were considered insane. Innovation always looks crazy until it works. Then it looks obvious. Jimmy's story is one example among hundreds, but it's particularly powerful because he wasn't a scientist or engineer or general. He was a mechanic, a sergeant, a guy with a high school education who learned from experience rather than textbooks. If innovation can come from someone like that, it can come from anyone. Modern militaries supposedly learned this lesson. Encourage bottom-up innovation. Listen to soldiers in the field. Reward creative problem-solving. But bureaucracies have short memories. Same resistance appears in new forms. Same battles get fought again. Same Hutchinsons blocking the same Jimmys for the same reasons. The story repeats because human institutions haven't evolved faster than human nature. We still resist change, still prefer rules to results, still punish innovation until success makes it undeniable. Understanding that pattern is Jimmy's real legacy. Not the specific repair techniques, not the aircraft returned to service. The lesson that systems must balance order with adaptation, that the person who challenges regulations might be the person who saves lives, that sometimes the craziest idea is the right idea. Just takes courage to try it. And now for the detail most people don't know. The thing that makes this story complete. Phoenix, the P-51 Mustang, rebuilt from trash. In 3 nights, the fighter that proved improvised repairs could work. She never made it to the Smithsonian. That was planned. After the war, Phoenix was supposed to be preserved as a historical artifact. Recognition of Jimmy's achievements. A symbol of American ingenuity. But in September 1945, during the demobilization chaos, Phoenix disappeared. Not destroyed, not scrapped, just gone. Missing from the records. For decades, historians assumed she'd been lost in the general confusion of post-war aircraft disposal. Thousands of fighters were melted down for scrap. Phoenix probably went the same way. Except she didn't. In 2003, an aviation archaeologist named Sarah Chen, Lieutenant Chen's granddaughter, was researching her grandfather's service record. Found references to Phoenix in old letters, started investigating, traced the aircraft through demobilization records, found something strange. Phoenix had been transferred to a maintenance school in Oklahoma in late 1945, used as a training airframe, then in 1947 transferred again. To a private buyer. Name listed as J. Kovač. Jimmy had bought his own creation, paid $350 for a fighter he'd rebuilt from scrap, shipped it back to Pennsylvania in pieces. Nobody knew why until Sarah Chen found Jimmy's neighbor still alive in 2003, age 87. The neighbor remembered. Jimmy had reassembled Phoenix in a barn outside Windber, spent years restoring her. Not for display, not for museums, for himself. He'd fly her sometimes, low and slow over the Pennsylvania mountains. Early mornings when nobody was around. The one piece of the war he couldn't leave behind. When Jimmy died in 1998, his will left everything to his niece, including the barn. The niece didn't know about Phoenix. Thought the barn just had old farm equipment. Sarah Chen tracked her down, explained what was inside. They opened the barn together in 2004. Phoenix sat there, covered in dust, wings folded, but intact. Every improvised repair still visible. The B-17 wing spar, the copper hydraulic lines, the fabricated aileron, the patchwork oil cooler. 59 years after Jimmy built her, she was still complete. The Smithsonian acquired Phoenix in 2005, but they made changes to the display plan. Instead of restoring her to pristine condition, they preserved her exactly as found, dust and all. They wanted people to see the improvised repairs, the mismatched panels, the evidence of a mechanic who refused to give up. Today, Phoenix hangs in the National Air and Space Museum's Stephen F. Udvar-Hazy Center. The placard tells the story. But next to it, they added something else. Jimmy's toolbox, the one he used in Italy, the one he used in that Pennsylvania barn, wrenches worn smooth from decades of use, a hammer with electrical tape on the handle. A measuring tape that doesn't quite retract anymore. Tools that fixed mining equipment and rebuilt fighters and kept working long after Jimmy was gone. Because that's the real point. Innovation isn't about genius moments. It's about tools and knowledge and determination. About looking at a problem and refusing to accept that it can't be solved. About making things work when everyone says they won't. Jimmy proved that in 3 nights in February 1945, then proved it again for 53 years in a Pennsylvania machine shop. Same man, same principles, different problems, same results. So let's wrap this up. From a coal mining town mechanic with a crazy idea to the man who changed how America fights wars. Jimmy Kovač rebuilt a destroyed P-51 using scrap metal in 72 hours. Defied a colonel who said it couldn't be done. Trained 200-plus mechanics who spread his methods across 2 continents. Returned 743 condemned aircraft to service in World War II alone. His innovations shortened the war by 3 to 6 weeks and saved 50,000 to 100,000 lives. Then his techniques encoded in military doctrine influenced 76 years of American military maintenance, returning over 15,000 aircraft to service across a dozen conflicts. Millions of sorties flown. Countless missions accomplished. Impossible to count the lives protected by aircraft that shouldn't have been flying, but were because one mechanic refused to accept limitations. Jimmy never wanted fame, refused recognition, went back to ordinary life and ordinary work. But his legacy lives in every Air Force mechanic who looks at a damaged aircraft and asks, "Can I fix this?" instead of, "Should I scrap this?" It lives in every engineer who understands principles matter more than procedures. In every leader who listens to the person with experience instead of just the person with rank. That's the power of innovation from unexpected places. The power of one person who sees what others miss. The power of making something from nothing, because lives depend on it. If you know similar stories of ordinary people accomplishing extraordinary things, share them in the comments. History is full of unsung heroes like Jimmy. Mechanics and medics and soldiers who changed outcomes without changing history books. And if this story inspired you, if it made you think about problems differently, about what's possible when you refuse to accept impossible, then Jimmy's legacy just grew a little larger. Because 80 years after he rebuilt a fighter in 3 nights, people are still learning the lesson he taught. You don't need perfect conditions. You don't need unlimited resources. You don't need permission from everyone above you. You just need to understand the problem, believe in a solution, and have the courage to try when everyone says you'll fail. That's how one mechanic with a wrench changed World War II. That's how Phoenix rose from trash to legend. And that's how the impossible becomes inevitable. One stubborn, brilliant, determined person at a time.